Hey guys, welcome to lesson 2, where we're going to talk about arithmetic sequences. And arithmetic sequences are just lists of numbers that have a pattern of either adding or subtracting. So it has to be one of those for it to be arithmetic. There are two types of formulas that we're going to talk about. There's the explicit formula, which we're going to talk about today. And then the other one is going to be the recursive formula. And they're just equations, like people call them like rules, or, you might see that. So like, that's why I put this down, like a rule or a formula. It means the same thing. So in your EOC or on your EOC reference sheet, this D is over here. So you'll see it both different, two different ways. It doesn't matter where the D is. These are just being multiplied together. So you'll kind of see them in two different areas. But this is called the nth term. And I'll kind of explain what that means here in a second. This is going to be your first term in the sequence. This is called the common difference. And this is what's being like added or subtracted to every time. So I'm going to say the pattern. And then this usually is going to stay. And again, I'll kind of talk about that when I talk about the nth term. So if I were to find, like if I wanted to find the fifth term, then this would be like a to the fifth, and I'm going to say 5 minus 1. So in here, so then like 5 minus 1 times the pattern, and then plus the first term. And that's how I would find the fifth term. So like if I had, I'm going to say, okay, and I want to find what that fifth term is. So this is term 1, term 2, term 3, term 4, term 5. Okay, well, the first term, that's going to be, I'm going to come down here, that's going to be 1. Notice what I'm doing. I'm adding 2 every time. So that's going to be called my common difference. And so if I want to find the fifth term, then I'm going to say 5 minus 1. And that's going to give me my answer. So let's see, 5 minus 1 is 4. 4 times 2 plus 1, that's going to be 9. So my fifth term is 9. So let's see, plus 2 is 5, plus 2 is 7, plus 2 is 9. So if you had, I mean, we could figure that out pretty easily, but if you had like the 105th term, that would be really helpful. So that's how that formula works. Okay, so right here it says find the common difference, then write the rule. I kind of, when we are writing the rule, I kind of like to put the D on the outside. But again, it's just totally your preference. Okay, so let's see. What am I adding or subtracting every time? So it looks like I'm adding 5 every time. So my common difference is going to be 5. And so I'm going to say A sub n, that's how you say that, A sub n equals, okay, so what's my first term? My first term is 1 plus, and it doesn't matter if you put the 5 in front or behind. It doesn't matter. I'm just going to do it behind. N minus 1 times 5. So that's how you do that. So now let's kind of figure this out. So this is, it looks like I'm subtracting 2 every time. So my common difference is negative 2. And so I'm going to say A sub n equals, let's see, my first term is 10. So 10 plus n minus 1 times negative 2. Okay, this one, it looks like I am subtracting 1/2 every time. So that's my common difference. And so I'm going to say 1 plus n minus 1 times negative 1/2. Okay, so now I have the sequence, and this is actually this is like one of our testlet questions. So let's see if we can figure out like what the pattern is. So I know that my first term, so like right here, that's going to be -5. So I can go down here and I can automatically get rid of those two. And so let's see, what am I doing? Am I adding 4 or am I subtracting 4 every time? So it looks like I'm subtracting 4 every time. So it's going to be answer choice B. Okay, so let's keep going. Write an equation for the nth term of the following arithmetic sequence. Okay, this is another way to say, just like write the formula. Use the formula on the reference sheet. Okay, so the formula on the reference sheet is the same one that we just talked about. But like I said, the D is just on the outside. It doesn't matter which one you use. Okay, so let's see. So it looks like here I'm adding 4, adding 4, adding 4. Okay, so my common difference is 4. So I'm going to say A sub n equals 7 plus n minus 1 times 4. This next one, it looks like I am subtracting 5 every time. So let's say I'm going to start off with 2, and I'm going to say n minus 1 times -5. This one, let's see, adding 3, adding 5. Ooh, so this one, notice I'm not adding, like there's a pattern, but it's not like the same number every time. So this is actually not a arithmetic sequence. So I just don't want you to assume that like everything has to be arithmetic. They can have a pattern without it being arithmetic. It has to be like the same number that you're adding every time or it won't work. Okay, so let's talk about if we wanted to kind of incorporate Desmos into this, what would this look like as an XY chart? Well, let's look at number 5. So number 5, our first term is 7, our second term is 11, our third term is 15, and our fourth term is 19. Let's do number 6. So our first term is 2, our second term is -3, our third term is -8, and our fourth term is -13. So feel comfortable with going back and forth. This is just going to be like your term number, and this is just going to be like the actual sequence number. Okay, it says arithmetic sequences always make a line. So we're going to see this here in just a second. So I'm going to actually type in problem number 5, and I'm going to show you on Desmos what that looks like. Okay, so to replicate this on Desmos, I'm going to go here, and then I'm going to go to table, and I'm just going to put those in. Like that. And if you'll notice, I really like this button. It shows that it is making a line, but I want to like actually connect the dots. So we're going to go here, and our arithmetic sequence it doesn't look the same, but it actually equals the same as this equation. So y equals 4x plus 3. So I'm going to write that down because it says what would the linear equation be of each. So y is equal to 4x plus 3. And we'll talk more about that here in a second. Okay, so what I'm going to do is I'm going to copy this down. And from there, I'm going to erase this up here. From there, I can go here and create a table. And what this is going to do is I can put in literally any term I want. So if I want like the 50th term of the sequence, I could just put that in. And this is really going to help us in a second. Okay, so I told you I would talk more about like the connection between the linear equation and the arithmetic sequence equation. So let me kind of show you. So number 5, we said that the arithmetic sequence was this. And if I distributed this 4, I'm going to have 7 plus 4n minus 4. And if I connected these, I have a sub n equals 4n plus 3. So if you'll notice, that's the same as my linear equation. It's just arithmetic sequences have a different look to them. Okay, so go ahead and try number 6 and put in the equation for that line. So I end up having y equals negative 5x plus 7 for that arithmetic sequence. That's the linear version of that. Okay, so again, it's very, very important to know that arithmetic sequences will always make lines. So tomorrow we're going to talk about geometric sequences, and they have a specific different type of graph. But arithmetic sequences always make lines. And something else that I want you to notice is, let's go back to right here. So this is our common difference. Notice how our common difference is the same as our slope. That is not a coincidence. That will always be the same. So look at this, common difference, slope. So that's something else that you can kind of steal if you like Desmos. You can kind of steal it out of the equation and then come up with your arithmetic sequence formula from that. Okay, so let's pretend, so I'm going to go back to number 5 on Desmos, and let's say that we want to find, so what this means is it wants us to find the 30th term in the sequence. Okay, so I'm going to repeat this with you again. So I type this in, and then I push this, and that's going to give me the line that I want. So that's what's going to help me create my table. So I'm going to get out of this previous, I'm going to create a table with that. And so once you have this table, it has to be the one that Desmos creates, not the one that you created. Then you can literally put in anything. So if I want the 30th term in the sequence, it's going to be 123. So it's just going to like keep on putting out whatever I wanted to. If I wanted to find the 500th term, I could do that. Okay, go ahead and try number 6 and see what you get for that. So 6, you should have gotten negative 143 when you type that into Desmos. Okay, let's look at problem number 8. So this is kind of nice because it gives us a chart. And so I'm going to go ahead and make a table from the chart. So I'm going to do 1, 2, 3, 4. And then just type in the y values. Okay, it says write a function that represents the arithmetic sequence. So I'm gonna point out something that I said a while ago, but just so you can see it. So I'm gonna use that formula. So a sub n equals my first term, which is 67, plus n minus 1. So let's say you're having a hard time finding this pattern. So I already have it up here. So I'm going to go here. And don't forget that your pattern is your slope. So I know that I'm going to multiply that by 17. So that's just a way to just like steal what you see off the Desmos. Okay, so once you have that, I'm going to go ahead and copy that and get the table off of that. Okay, so it says you end up with a $254 bill for the party. How many people can attend the party? Okay, so you can either put in 254 here, or unfortunately you can't put it in the Y value here, but you could put 254 in for this. And when you do that, it creates another straight line, just like we've talked about with solving. And then you'll have to zoom in, but it ends up giving us 12. So let's see, I'm going to go back. Okay, so right here. So let's just test it. So if I put in 12, do you see that gives us 254? So, so I can invite 12 people to my party. Okay, that is it. Let's go to the last page. I'm going to keep up Desmos because I'm going to show you something that's kind of nice on Desmos. And you can use it, you don't have to use it. So it says to find the first 4 sequence, the first 4 terms in the sequence. So I know that that's going to be my first term. So I know it's 27. And then I know that I'm subtracting 4. So literally in your calculator, you could just put 27 minus 4 and get 23. and then subtract 4 again and get 19, and then subtract 4 again and get 15. So it's really pretty easy. But if you want to plug in the formula into Desmos, you can also do that. So let me show you. So if you go A and then you go to the ABC, and right here, this is that subscript where you could put A sub n and then equals 27 plus, and it actually lets you use like n minus 1 since it's talking about a sequence. So it looks like that. Okay, and then once you have that, it will let you create a table. And so you always want to start with like sequence 1. So notice we already have the first term is 27, the second term is 23, the third term we said is 19, and then the fourth term is 15. And so now that we have it up here, I'll just show you, like if I wanted to do number 10 on Desmos, and again, like it might be just as fast to do it in your calculator or like in your head, but just know you can just kind of move around these and it already creates the chart for you. So like this is -2, so like we're right in here, -2, 3, 8, and 13. Okay, so go ahead and try to do 11 and 12 and see what you get. Okay, so these are the 4 terms for 11 and 12. And again, you could do it on Desmos, you don't have to. Okay, so let's go on to 13. So 13 through 18 are just kind of like just various word problems. And you just kind of have to roll with it. So let's see what it's asking us to find. So find the 4th term of an arithmetic sequence if the first term is 2 and the common difference is 5. Okay, so I'm going to say A sub n equals, let's see, first term is 2 and the common difference is 5. So it's going to look like that. So again, we can type this in, but we also know that the first term is 2, and then I'm adding 5 every time. So 2 plus 5 is 7, plus 5 is 12, plus 5 is 17. So the 4th term is just going to be 17. Right here. Again, we just talked about how you can do that on Desmos. That's fine. Notice that sometimes it kind of flips back and forth. So like, notice this looks very linear, which it is, but I think you can type this into Desmos and then we can easily put in the 30th term for that. So let's see. So A sub n equals 3 n minus 2. And then I'm going to do table. Yeah, that worked perfect. And then I'm just going to type in the 30th term and I get 88. And again, I mean, you could have easily put in 30 here and done the math yourself. Okay, so this one, so it says find the first 3 terms of an arithmetic sequence that's 9n minus 21. Okay, so I'm going to switch this up. So we have 9n minus 21. And so I don't know what those first 3 terms are. So I'm going to go here and look at the table. So it looks like my first term is -12. My second term is -3. And my third term is 6. And so remember, this is my common difference right here, that slope. So I can easily write the explicit rule. So I'm going to say, let's see, my first term is -12 plus n minus 1 times 9. And that is the same rule that's equal to the linear equation. Okay, let's look at number 16. So if the first term is 8 and the second term is 13, find the 50th term. Okay, so there's a couple different ways that we could do this. We could do this with arithmetic sequence, but I'm going to show you how we don't even have to use an arithmetic sequence here. Okay, so if it gave us the first 2 terms, So if term number 1 is 8 and term number 3 is 13, or sorry, number 2 is 13, then I'm just going to go ahead and pull that equation out and make the table. So it says find the 50th term. So I'm just going to type in 50. And so I'm going to get, I'm just going to do ... This is the 50th term is 253. So that would be my answer there. If I had to find a rule for that, let's see, I can find it pretty easily. So my first term is 8. And then I'm going to say n minus 1. And then we can see that the slope is 5. And so I'm going to call that 5. Okay, let's look at number 17. So 17, let's see, my first term is 30. My second term is 24. What is the formula for the sequence? Okay, so I'm not going to cheat on decimals. Let's just kind of do this. So my first term is 30. And I'm going to say n minus 1. And then my slope, what's my pattern or my common difference? So notice I'm going down by 6. So it's going to be negative 6. And that is it. And then I could find whatever term I wanted to after that. Okay, it says, finally, number 18, the first 3 terms of an arithmetic sequence are these. Let's see, write a formula to express the nth term. Okay, so again, we can do this. So I'm going to say a sub n equals 5 plus n minus 1 times d. Okay, so again, this is what I'm saying. Like, it might be faster to just figure it out. Like, what's a pattern? What does it keep going up by? But if you're totally lost, you still just feel free to go here and then type in those terms. So 5, 17, 29. And again, I'm going to get, so right there, right there, that is my slope. And so that's what I'm going up by. That is also my common difference. And that's it.